Good morning and welcome to RobotsConf. We are so excited to have you here. My name is Laura Williams and this is Chris Williams. We are married. My daughter, Virginia Williams, is down there, and we also have an 8-month-old Cameron Williams. So this is really, truly a family event for us. They come everywhere with us.
If you ever want to get a view of a 3-year-old's perspective of a conference, she's baby Virginia, and he's Robot Cameron. He's over
on
there.
Twitter.
On
Yeah.
Twitter.
So you can follow them if you want.
So this is a very special event because it's the first one of its kind. It's the first RobotsConf ever. So thank you very much, everyone, for joining us on this wonderful, crazy journey. Just so you know, if you have questions about the schedule, that's intentional. This is a whole new format. We're trying a whole bunch of different things. But don't worry, we will take care of everything, and we will make sure that you get to the right places and get to see and do everything that you want to do. The most important thing while you're here with us is to explore, try new things. Everyone should have a wristband, at least one. The wristband is actually here to help you explore, but also stay in the comfort zone of the languages that you prefer. And that's sort of the idea, is that come together as developers and leave as a maker, but yet still be comfortable in our developer sort of world. And the hope there is that the language bridge will work very well. The one thing that we do ask is that your RobotsConf badge, you wear that throughout the entire event. This is going to give you access to the food, so it's more important for you to wear it than it is for us to make sure you wear it. So if you want to eat, make sure you wear your badge at all times. When you checked in today, you got the thing that we had mentioned on Twitter about making sure that you left either a space of carry-on or a space in your luggage. Wanted to call up a couple people who helped make that kit as amazing as it is, and also because there's a lot of things in here that you may not have ever seen. So I'm going to start with the SparkCore team. Come on up. And this is a very special one, because it's actually his birthday. So we're gonna sing happy birthday as he comes up. Happy birthday to you. Happy birthday to you. I was told to do this. Happy birthday, dear Zach. Happy birthday to you.
Thank you, that was terribly embarrassing. Well, hello, everyone. So I'm going to just get plugged in real quick. My name is Zach Sapala. I am one of the founders and the CEO of a company called Spark. We make a product called the SparkCore. It's in all your boxes. It is a product that lets you make an internet-connected thing really quickly and really easily. All right, so first off, we launched this product, SparkCore, on Kickstarter. Who here happens to be a backer of our Kickstarter campaign? Awesome. Okay, so there's a bunch of folks out there. We launched a campaign in May to June. We've been spending the whole summer and fall developing the product. We just started shipping last week. So you know what the product is.
This is the internet. Well, maybe not the internet you're used to. This little guy connects to the internet over Wi-Fi. And when he does, he brings along whatever he's connected to. Power outlets, buttons, cameras, remote control cars. And when the internet spills over into the real world, exciting things happen, like toys that learn, or lights that know when you're home, or Wi-Fi PB&J. With the simplicity of an Arduino and the power of an ARM chip, this is the SparkCore. I'm Zach from the Spark team, and we're in China. We came here to join Accelerator, the premier incubator for hardware startups. Accelerator is based in Shenzhen, the electronics capital of the world, and a great place to build something new. We've spent the last year creating Wi-Fi connected products. A lot of people are building connected things, but we all struggle with the same problem. Adding Wi-Fi to a product is either very difficult, very expensive, or both.
So we built the SparkCore. This little board solves all the problems with making Wi-Fi connected products. The setup is seamless and everything's secure. It runs the Arduino code you're used to, and you can program it wirelessly. This means it's a lot easier to add Wi-Fi now, so we hope you'll build it into your own projects, and maybe even find it in some products off the shelf.
Gosh, it's crowded in here. With the help of our friends at Hexcelerator, we've already started making cool projects with the Spark Core. Here are a few of our favorites.
First, there's a robot you can control with your phone. Nice driving, Kenny. Or this awesome pizza orderer. Just flip the switch to arm the button and press it to irreversibly order a hot, delicious pie right to your door.
Well, it's gonna take 45 minutes.
And finally, an LCD fridge magnet that displays your favorite Twitter feed. The possibilities are basically infinite.
Now, we're heading home to the States, but the real journey begins here. Back our campaign to get your own Spark Core and come along for the ride. And then the only question is, what will you build first?
So that was 6 months ago, and then we made it, and we actually manufactured 13,000 of these things, and it's called the Spark Core. It is a Arduino with Wi-Fi, so it's fully integrated. It's got a Wi-Fi module on board. It gives you a REST API to interface with your hardware. So it connects to the Spark Cloud. We have a cloud service that these connect to, so that you have an API that you can connect to and control and interact with this device. You can flash it with new code over the air, all these really cool things. And it's all open source. We wanted to make it really, really easy to get set up with. We have an iPhone app and an Android app. So when you get started, go search Spark Core in Google Play or the App Store. You can find our app. You can download it. It'll set it up for you. It also has this interface that we call Tinker, where you can just like tap on the pins and be able to write and read sensor values, turn LEDs on and off, motors, whatever it might be, without actually writing any code. When you're ready to write code, we have a web IDE where you can write very simple Arduino code to basically put your own program on the Spark Core, hit flash, it'll send it wirelessly to the Spark Core, and then you can also interact with that through the API as well. So a few caveats. You guys are our first users. We, like I said, we made 13,000 of them, but we started shipping this week, and they shipped from China. So only about 10 or 20 people have received them so far. So this is the first time that we're actually putting hundreds of people, hitting our servers and actually seeing if this stuff works the way that it's intended in this kind of environment. So first of all, thank you for going down this with us, and also please be gentle and forgiving because things will break. We are here to fix them. And be honest with us. If the documentation isn't clear, if you're not quite sure how things will work, if you don't like this particular method of whatever, tell us because we want to fix it. A few things to let you know about when you work with this. You need an antenna. They're in your boxes. They're these little yellow things on a oh. There you go. There's an antenna. I have no idea where I'm pointing this thing. There it is. That's an antenna. So it plugs into the bottom. So if it's not working, this is probably the first thing to check. There's lights on the Spark Core that will come on as it's going through the setup process. Blue means it's listening for Wi-Fi credentials. Green is connecting to the Wi-Fi network. Cyan means it's connected, and magenta means it's flashing the code. It's either auto-updating the firmware or it's flashing code that you've written. There is a process for claiming a core, associating it with your account, so you have control over it and nobody else does. It doesn't work well here because of the network, and so when you're ready to get started, come to us. We basically are setting up a booth to claim everybody's cores to your accounts. So when you're ready to get there, come chat with us. Be forgiving. This is brand new. We're just. This is the first time, so we appreciate you guys working with us. And when you have problems, tell us about them and we'll fix them. We set up a couple times for you guys to work with us. We can help you get started at 11:05 and 1:05. We're doing from 0 to connected, so we'll get you started if you haven't gotten there already. At 4 o'clock, we're going to give a lesson on how to use our REST API, and at 4:30, we're going to do a deep dive on writing your own firmware for the Spark Core. There's 4 of us here today. My name is Zach. We have Zachary, who's the CTO. We have David, who is a software developer, and Will, who is a hardware guy, spent the last 6 months in China. And so come chat with us. We're wearing the Spark shirts. And when you're ready to get started, spark.io/start.
Thank you very much. Do you want your laptop? I mean, I'll take it. There you go. So Spark represents, like you said, we are sort of the first people able to use it, and that's a really exciting thing. That, for me, is one of the things about RobotsConf. It's all about exploring, doing new things, and trying things that are on the cutting edge. The other one coming back, Leap Motion, come on up. Also in your kits is a, probably you found it, a Leap Motion controller.
It looks like this. It's got a cable. It's a little USB device that I'll talk about right now, what exactly it does. So Leap Motion, we create a small little controller. The idea is to connect the human hand with the computer in a much more natural way than any other interface. The keyboard and mouse have been around for a very long time, and it makes sense as it's essentially pulling, it's forcing the human to adapt to how the computer can receive our input with buttons. And back in the 60s, we came up with the two-dimensional mouse to select points. But really, this is a far reach from what we're trying to do to humanize technology and allow the computer to understand our own natural gestures, things that we've been evolved to understand and know how to do very easily, things that we do every day, picking up a box in real life. This is the types of interactions that's natural for all people. It doesn't have to be a learned experience. And I'll give you a couple of demos of some things people have built and talk about what exactly you can build with this today and the next couple of days at the Robots Conference. First thing I want to do is show a robotic arm that someone in our community had put together.
Hi, I'm Yu Jang. I built this robotic arm that's controlled by an Arduino and a Leap Motion device. So let's fire it up. So as you can see, it tracks my hand pretty well in free space. So let's try to pick up this ball of paper here. Set it on top of this can. Not bad, huh? So that's the Leap Motion controlled robotic arm.
So Yu Jang here, he actually built this robot in a matter of less than 2 weeks. He spent 3 or 4 days putting the software together. He used Node.js, found some inverse kinematics to, given the point of his hand that our API produces, able to move the servos around and control this robot. He said he had never really built any hardware projects before this in his life, and doesn't have a background in the physics modeling of this at all. Was really happy with putting this together in a matter of 2 weeks. One other thing I'll show you is a quadcopter experiment that was done in 24 hours, actually.
All right, we're back. It hasn't quite been 24 hours, but I'm here with Milan of the CPIX Twitter team. Got Rahama on the camera now, but Milan has already picked up the SDK and done some cool stuff with it in LabVIEW. Show us what you got, Milan.
Yeah. So we took the SDK, we broke it out essentially into 2 functions. All we have to do is open a connection to the device, and then inside a loop we read measurements off the device pretty quickly. And
yeah, and that's the Leap SDK over here?
Yeah. So this is the Leap SDK. So the SDK includes this visualizer, which lets you track the motion of your fingers. And we thought it was cool, but we wanted to try something a little bit different with our actual LabVIEW.
Sweet. So now we're in LabVIEW, and we can see the values on the front panel here.
Yeah, that's some stale data in there. So we'll go ahead and start it up, collect some new information.
Cool.
So what we wanted to do is we wanted to interact with something physical.
Oh, I hear something firing up over there. Rahama, you can get that one, and I'll start a camera over here so I can keep on what Milan's doing.
So what we have over there is a quad rotor that's reading the measurements that we're sending in from the Leap device. Okay, so I can actually sit here and control the quad rotor with my hand.
Pretty quick response.
Yeah.
Awesome. Milan, well done.
So as you can see, there's a couple of great examples of controlling things in the physical world with the Leap Motion controller. One more I want to show you is one of the reasons there are two main reasons that we built this technology in the first place. One, it was 3D modeling and actually creating and 3D information with this controller is more intuitive because you have a full 3D input, 3D space to perform input. And another one is manipulating objects. I'll show you an app that we had an intern build a few years ago, last summer. It's called Block 54. It's a lot like Jenga, which is the block game that you pick up with your hand. Come on. So here I can just grab in the space, grab a block, pick it up, and stick it right on top. And so maybe you could build a robot arm that actually plays Jenga in the physical world with the Leap Motion controller. Wouldn't that be kind of ridiculous? But you could do it. I want to very quickly show you what our tools are so you can get started today. And then I'll mention the workshops that we'll be doing in the next day or two. So the first thing you'll need is actually our software. You can download that from leapmotion.com/setup. I'll have a list of links at the very end. The software development kit, you'll find at developer.leapmotion.com. And we support out of the box 6 different languages: C++, C#, Java, Python, JavaScript, and Objective-C. We also have community links. There's a community-provided Adobe Air and Flash extension. We also have processing library support. There's lots of really good tools. We have a great community forum that provides these things. You can see we have a JavaScript, a dedicated site just for JavaScript because there's a lot, a very enhanced API in that language because of some clever things you can do, both in Node and in the browser. We have some comprehensive tutorials there. It's a totally open library on GitHub. Here you'll find the ActionScript one is also on GitHub. Processing as well. Cylon is here, and Cylon just in the past 2 weeks actually integrated Leap Motion support. This is a cross-input and cross-output and robot library. There's an example if you check out this website, controlling the Sphero, which is I think we have a few Spheros here at the conference, a little rolling robot. So you can control the Sphero with the Leap rolling around, play a game. This is totally integrated right out of the box. You can use this. And we also have a community portal right here. Where you can find things like Unity examples. We've tried to provide as many tools as possible, things to get you started. We have an SDK with many different examples built in, so you can, for each language, there's something to get you started. And the idea here is what we're trying to do is make sure that you can build something really awesome, both to play around with things in the physical world and help us, push how computers interface with us more so than we interface with the computers. Because we want to humanize the technology and make it easy to interact with things so that it does not take years and years of training to do something like sculpting, for example. Maybe this is something that would take, as an example, AutoCAD has a very complex interface to manipulate. But if we can make it simpler so you can reach into the computer and actually directly interact with that clay molding application, then you can build something without having a steep learning curve of how to control things. And I'll let Zach give a quick demo of our freeform application, which is a clay molding thing, and with a surprise twist at the end. Sure, let me narrate while he does his clay molding. So the freeform application lets you load in a model. It could start with a little blob. In this case, someone has already built this. We've kind of got it started it for you. This is a vase that someone has built. You can spin the clay around and rotate it up. You can spin the clay around and as if it's a pottery wheel. You can paint it. You can sculpt it. You can push and pull, repel. all with just reaching your hand right in. Zach hasn't played around with this application that much. We've actually given this application about a month ago to a professional sculptor, and he was able to produce some things that look a lot like something you'd actually see, cast in bronze and put somewhere. I guess I might have shown you an image on our app store, one of the cover images for it. It's really amazing when you spend a little time to learn what you can build with this. You can create some cool stuff. And we allow you to export this in all sorts of different model files. And we have some 3D printers on site, and we were able just last night to take this vase and 3D print it. So you can reach right into the computer, build a little vase like this, and print it out. You get a physical representation of something you created in a virtual world with this 3D input controller. So everyone's kit has a Leap Motion controller in it. Later on today at 2:45, I'll be giving a 20-minute talk about the interaction interfaces, both with Leap Motion and many other styles of input with different remote controls and gestural input, 3D object scanners, that sort of thing. And tomorrow I'll be doing 2 different workshops to get you started, to really, maybe you can start thinking of the ideas of how you might want to use a Leap or another type of input device to manipulate a robot you build today. And then tomorrow we can actually, once you have the wheels spinning, we can get the interaction with your hands to control it effectively. If you have any questions about Leap or really interaction of any kind, please look for Zach and I. We're wearing these black shirts that say Leap Motion, and we'll be happy to help you as much as possible. Thanks, and we hope you enjoy the Leap.
For everyone standing over there, there are plentiful seats over here, and nobody over here bites or anything. So head on over, grab a chair. And with that, Worley, if you want to come on up, we'll go ahead and get started. So while Worley's getting up here and getting set, just a quick idea as to how the day is going to go. We're going to be in here until about 3:45 with appropriate breaks throughout the day. The goal for this part in the beginning is to give you guys a global view, a visionary, very broad stroke of the amazing things that are possible in the next 24 hours or 48 hours and beyond. And so don't necessarily get worried that some of this is super crazy, because it is, but that's the point. Just sit back and enjoy. And then after this, we will have our workshop guides come up and provide quick surveys of the various different discrete areas in the maker movement. The goal of that being that you get a very quick and very broad overview of everything that's available. And then after that, we break out into sort of free-form hacking spaces where our guides will be there to help you do whatever you want to do. We're going to ask that you get into small groups between 2 to 4 size and then build things from there. And there's no instruction as to what to build, so you can build whatever you want. That includes using any of the 52 drones that we have here, any of the 20 some odd Spheros we have, any of the Romotives we have, any of the solder stations, everything. It's a playground over there. So there are first aid kits. Just be aware of that. There are fire extinguishers. We've got that under control. Hopefully we don't have to use them, but they are all ready just in case.